Well, Khalil, thank you very much. It's a pleasure to be back at the University of Michigan. It's been a few years since I've been here. I don't recall anything like this in East Quad or West Quad, East Engineering or West Engineering, because I spent many hours there. I do remember coming to North Campus on a few occasions. We were talking about it this morning. Nubs, was it? Was it Nubs? I used to do computing in a building next door, and I'd have to come here in the middle of winter. There were no other buildings here. Submit a deck of cards. You guys don't know what that is. We may know what it is. And 2 hours later, learn that one of my cards was out of sequence. You know what it is. So it's terrific to be back. It really is. And I'm going to spend a little bit of time this morning giving you a context of where IBM is headed. What do we see as some really interesting areas of future technology development? And I really want to inspire some thinking. This isn't a view graph. This isn't a view graph talk. You can look at the charts. They're sort of interesting. But I really want to have a dialogue in terms of where's technology going. And there are a number of things that are critically important over the next few years, especially now, in terms of the role of government to support fundamental research. Where is this AI revolution going to take us? What's the next big thing on the horizon? How should we be thinking about new technology areas? What are the big drivers from industry that will take up these ideas and actually implement them in ways that will have a fundamental impact on us as a people, on our nation, and the things we care about? So I'll say a little bit about each of those, but I'm going to kind of use a little bit of eye contact. I may ask some questions, but I'm going to try and keep this conversational. I actually want to start with a little bit of context. Again, context in my time here as an undergraduate. I had great fortune to having many superb professors. But there were three that sort of stood out in my career as mentors and people that I, sort of looking back a little bit, realized they really had a big impact in my career path and my passion for the profession. My first engineering course was with Professor Ferris. And as a freshman coming here from Lexington, Massachusetts, pretty far from home, he gave me an appreciation of engineering as a profession. And he challenged us to think about it, not so much with the coursework, we did a lot of that, but there was a deeper set of questions that he instilled upon me and sort of got me to understand the importance of electrical engineering as a profession. And it went beyond the coursework. The same was true a few years later when I had my first antenna course with Professor Tai. Kind of a quiet guy, very subtle, but a remarkably deep thinker. And I remember that course. I remember solving the dyadic Green's functions for surfaces that I didn't understand and spending hours on this thing, those decks of cards that came up here that were never quite right. But the discipline that he instilled on me in terms of where this profession could, how I could contribute to the profession, remained with me a long time. And then the third fellow that I spent quite a bit of time with that also inspired me was Professor Khan. I took my first microwave device course with him. Professor Haddad, I think, was here, but wasn't the chair at the time. I think Professor Lyon was, John Lyon, I think, was the chair of the department. But Professor Khan instilled upon me the inquisitive nature of this field of microwave theory and what I could do with remarkably small devices. I learned about impact diodes. I didn't know about impact diodes. I thought it was pretty interesting. And I went on to my graduate work to do some work in solid state device physics and device technology. So I look back at my career, my time here at the University of Michigan as setting a foundation, but really it came down to a few people that really had a big impact in my career path. And I really do appreciate them. None of these folks are here today. It's unfortunate, but they all had a big impact on the way I was thinking about engineering as a profession, coming out of a pretty small environment previously to a big school that was kind of overwhelming, and they had a big impact on me. So when I joined IBM Research in December of 2012, it was also a big transition. 400,000 employees. We've got 3,000 researchers across 12 global laboratories, talent that's unmatched. We could argue it, but I think I'd win. We've got remarkably deep talent across many laboratories. And I work day to day with teams of researchers that are asking really hard questions and answering them in really unique ways. And I met with some graduate students this morning. We talked a little bit about this. The ability to work with teams across many continents on a day-to-day basis. My day started today with a call before we met this morning to Zurich, to the research team there that's working in nanoscale structures. And I'll have a call this evening to our team in Delhi that's working on the future of blockchain. And it's a 24-hour cycle. But there's remarkable talent across each of these sites. IBM as a company has made significant investments in research and will continue to do so. It's a core part of our business. And across my career, I haven't seen an organization that's quite structured this way. Lots of companies have research organizations, but ours is a bit unique in that our researchers are expected to be the leaders in their field, as defined by their publications, their interactions, their external recognition. But they're also expected to take that work and have an impact with a client that can actually use it. So it puts our researchers in a little bit of an uneasy situation. We talked about this morning. You have to be in this intersection of the world of the possible and the world of the pragmatic. Clients have no understanding of how to solve a Hamiltonian. And yet our quantum research group is doing exactly that work and more. And to take a research community that understands the core tenets of a field and apply it into a business area that can have an impact is really when really magic things happen. And we do this across the board. I'll give you some examples of this throughout my talk, but that's the crux of really why I wanted to be part of IBM Research. Could have gone to a lot of places, but I wanted to land in a place that had remarkable technical depth and the ability to take that depth and scale it for impact in a number of areas. And we're doing that, and you'll see some of that today. The numbers on the bottom are interesting. Big numbers are good. We've got a lot of big numbers. Leave it at that. About 4 years ago, we started looking at this intersection of social, mobile, and cloud computing, the availability of enormous amounts of data on a cloud platform and how that's starting to play out in the Internet of Things, where the availability of sensors is now ubiquitous. New types of sensors have emerged in industries that haven't had them before. And the availability of data is now the core of many business propositions. And our research community, our teams across that enterprise that I showed you, are working at that intersection. And what becomes interesting, whoops, your system reset.
Yeah.
It must be an Apple. It would never be an IBM designed Lenovo. By the way, we sold the PC division of IBM to Lenovo. And I've visited Lenovo a bunch of times. They're actually not too far from our lab in Beijing. And when I go to Lenovo, it's like going to GM manufacturing. Huge facility, right? Huge facility. We still have IBMers there. They have folks at our place, and we still support it. So I know how to fix a Lenovo. I have no idea how to fix an Apple. You don't have to fix Apples, right? So this intersection of mobile, social, and cloud computing is driving every discussion that we have. And the core of this is what information, what data is available that you can actually analyze. In every one of these industries, whether it's transportation or finance, commerce, I mean, you see this today with Amazon, you certainly see it with other companies like that. They're all trying to build insight from transactions on data that's not transactional data, but it might be bursty. It might be video analytics. It might be video data. So the types of data that we're trying to understand aren't the traditional data sets. They're these new data sets. And so understanding that and building those insights in a time-critical way is becoming the new economic engine for every industry that we're involved in. We recognized this a few years ago, and IBM has made investments and research teams in every one of these areas. We've got teams working on the world's smallest computer, 100 by 100 micron computer that will have embedded blockchain, and it will be used in IoT applications to secure physical transactions. We've got a team working on that. We've got another team working on neuromorphic computing to transition our traditional architectures into approximate compute and precise compute at the right composition for the right data set. We've got other teams working in each of these areas. And the magic here is to bring these teams together to build just the right first example that we can demonstrate to clients and start building out an industry in a bunch of these areas. So that's kind of what drove a number of these transitions a few years ago. And as a result, IBM has transitioned its core business, not just the research piece, but the big IBM piece, from a company that's delivering hardware to a company that's now delivering insights on a cloud platform. It's a huge transition for a company, a $150 billion cap company. It's a major transition, and you're seeing this in the market. By the way, last week, this is not a recommendation, it's just an observation. Last week, our stock jumped 10 points. It's a pretty big deal. It was a nice day for me. It's a nice day for a lot of us. That increase of 10 points resulted in a 70-point increase in the S&P 500, just because of the IBM improvements. So we carry a lot of value with the company and with the industries that we serve. We recognize this transition, and we're shifting the company. We are shifting from a company that was delivering hardware to a company that's now delivering insights on cloud platform. And as a result, we need to rethink, and we need to invest and develop and drive new work in each of these areas. Extracting insight from ambiguous data. We were talking this morning about healthcare. There was a student, who was it, who mentioned, I forget your name, you're probably here somewhere. I forget who it was, the fellow, doesn't matter. I mean, is he here? Yeah, you asked the question. Great question. What's the next set of impacts that you expect? What are the big technology transitions that you expect? What are the next big opportunities? And I said, well, there are really two. One of them is going to be in artificial intelligence in some fashion, and we'll talk more about that. The other is going to be in delivering new healthcare, new ways to provide healthcare to a global world in a much more affordable way. And so we're looking at that, and we're driving solutions for both of those. But this was a big transition for IBM, and it is founded on insight and research that's going on across IBM Research globally. And as I look at this, there are sort of 5 areas that come to mind. What might the future hold? Where are the big investments? Where are the big ideas? And by the way, when I say investments, it's not like an investment banker. I'm thinking about research investments, like talent, things that you guys care about. What sort of work would we like to do? Where are the next big opportunities? The first is in extending AI systems to be embedded in the world that we live in. To extend, and I'm not talking about just driverless cars, I'm not talking about just another version of Siri, I'm talking about how do we think about building systems that can interact with us in a very personal way, helping us understand ambiguous data and gather insights for which we can make decisions and choices. How can we build systems that can help us and augment what we do? So we certainly have work in that space in AI at the edge. and this really touches upon compute at the edge, very low power systems, very low latency systems that can provide insight at very low cost. We have work in cognitive education. We have a big effort across IBM Watson, for which research is part of, to help understand what information is best to present to a student so that student can actually learn that more effectively. We're doing this K through 12, but I can imagine extending it. The uptake for a graduate student might be faster than a 4-year-old. Hopefully it is, but we could run that experiment. But it's kind of interesting. The question is, how does a teacher present information to a student at the right tempo, at the right content level that the student really understands? A professor will do this. Your advisors do this every day, right? They give you hard problems, but not impossible problems. Maybe they give you impossible problems. But the challenge is giving a student a problem that's just hard enough that it doesn't discourage them, and it actually is solvable in a period of time that actually matters. So you can do that by watching the students' interactions, by listening to the students' dialogue, by watching the tempo of what's happening, by reading the student from a distance. And we have work going on in that space on the products that we're delivering, and more importantly, on the research agenda that underlies all of that. And again, IBM Research is about setting this foundation of research to support a set of products that we're developing. The things that we do really well across research is setting that technical foundation. By the way, we'll get you guys copies of all the charts if that helps. The things that we don't do well across research is scaling it out. And that's also the challenge across academia, right? It's easy to publish the paper. My team loves to publish the paper. I call it polishing the 5th and 6th digit. We love to do that because we've polished the first 3. Getting the next 2 right, I'd better be in PhysRev next month or I'm not going to be relevant. You've got to do all of that, but you've got to take that and then drive it for impact. So in this area of AI everywhere, it's an open space. It really is. There's lots of work going on in what I'll call non-traditional environments, where we're working with data sets that are non-traditional in areas that you wouldn't normally expect. And we're starting to build teams across our global labs to explore that. Reimagined engagements is another area. I'll point to the work that we're doing in blockchain, remarkably effective. Everyone here is an IEEE member, or many are. You saw something in Spectrum, I think last month, on blockchain. Pretty interesting article. If correct, and we think it is, this idea will fundamentally change the way multi-party transactions are done. Now you think about that, boy, that sounds pretty interesting. I have Bitcoin, I've never quite used it. This is not about Bitcoin. This is about changing the way international trade is done, where you have dozens of parties between multiple countries building synchronous record of what's actually transitioned from Rottenburg to Johannesburg, by example. We've looked at this. Shipping containers from point A to point B is enormously expensive, especially if it's by ship, combination air, combination ground, where you have parties at each end that have to certify that transaction, and there's real money involved. If we could use blockchain to validate in a ledger, in an infutable ledger, that there's a sequence of events occurred, you can't tamper with it because it's open. You really can't tamper with it because it's been designed as such. You then have a way to validate where the value is in that multi-party transaction. And we can reduce a lot of the cost of transitioning goods from point A to point B internationally. So for us, that's a big, big deal. And for us to do that, we need to work with shipping companies, we need to work with governments that have, trade organizations, we need to work with industry organizations, and we do all of that. Researchers work across that entire supply chain to really understand what's it take to certify that multi-party transaction. If you many people here have bought property or bought a house maybe some recently. Think about the nonsense that we go through and what has to happen for you to actually move into that house and get the key. You've got to deal with banks, attorneys on both ends, you've got a seller, buyer, you've got a tax, you've got a tax liability here, you've got local taxes there. It's a multi-party transaction. And unfortunately, the buyer is the one that has to pay in this whole supply chain. So it's a very cumbersome environment. And we think in many of these areas we can shorten that and provide that value to every party to see a synchronous event, and we're doing just that in cognitive blockchain. So these engagements, these ways that analytics, maybe AI, and transactions will be handled in a multi-party event turn out to be a pretty big deal across many, many industries. Personalization at scale and instrumentation, those all are being driven by the explosion of sensors that we all are seeing globally. Jarir and I rode here this morning in his rather new and pretty spiffy vehicle. I won't say what it is. Rather new and very spiffy. Lots of sensors. And the thing that impressed me about it, other than it was a really nice car, is the fact that all that stuff is kind of hidden. It all works. You don't have to think about it. I don't know how many processors there are in your Lamborghini, but there are quite a few. It wasn't a Lamborghini, but there were quite a few. There's got to be 100 processors in your car, maybe 1,000. And these things all interoperate. They generally all work, or you would not have bought the car. And they kind of work in the background. And having things that are personalized to you is going to be the next step towards that path. We've done a lot of work with many of the automotive companies. I've spent a lot of time here and also in Stuttgart, Germany, actually Sindelfingen, Germany, with another automotive manufacturer, on exactly that. In fact, these transitions are occurring so rapidly and such a scale that these industries are fundamentally going to change. The role of the automotive manufacturer isn't going to be to bend metal and provide 5,000-pound blocks of commerce on your, delivered to your house. It's going to be to deliver services, one of which is transportation. In the same way Apple provides this to provide services, one of which happens to be a telephone. The telephone's sort of interesting, but it's not really interesting. It's the other applications that are more interesting, right? And you're going to see every one of these industries move forward in a very new way. And what's exciting for us as engineers and as researchers, that opens up a whole new area to start thinking about what's the next thing going to start looking like. So personalization, engagement in an instrumented world, in ways where AI will be embedded, all those are going to be part of this. And we've got work going on in each of these areas. There are three areas that, in particular, I want to call your attention to. And these are really at the core of our AI bet. So we talk about IBM Research AI as a significant part of the IBM Research agenda. Again, 3,000 researchers globally, maybe half are in this space, maybe even 2/3 touch this space. So it's significant. John Laird and I have been talking about this for 20 years, 10 years. John, you and I, this concept of comprehension and understanding, absolutely essential. And we're just now starting to peel that onion. I'll give you the example in Haifa, at our lab in Haifa, which, by the way, is right across, within walking distance of the Technion. Terrific location. That team is working on video analytics to understand, in a storefront, how do I build a model for how shoppers are actually interacting with the placement of goods in that store? Could I be more effective in where I place goods and what goods I place in order to increase the revenue of the stores? They're working with a number of clients in that space. And it's all about understanding video analytics, not to recognize a dog or a cat or a parrot in a picture, but to recognize what's the sequence of events, how's that likely to fold out, what's the business impact going to look like. I mentioned this morning to the students we met with. When I look in this room, I don't image it in pixel space, right? I mean, I've never been to this conference room before. Pretty impressive. I'd say it's a conference room. It's got to be a conference room that's near maybe the department office. You'd never see this in a lab, right? But you build context by imaging, not in pixel space, but in real space. And building systems that can understand the context without having to go through the recognition of each object in the field is the work that we're focused on. So identifying a bird in a jar, kind of a silly problem, but it's a really hard problem. And doing that, not recognizing pictures of every bird in every jar, but by recognizing immediately, I see something that kind of looks like this, I've seen it before, it's close enough, I can say that's what it is, with some degree of certainty. That's a body of work that we're involved in. The second area, learning and reasoning. There's a major disruption that's going on now, and we've got a lot of work in this space, and you'll see it in our published literature, in our publications and literature, in moving from a world of precise computing to a world of approximate computing. Big implications in computing fabric, computing architectures, from an x86-like architecture to something that looks much more neuromorphic. It's going to look more systolic. It will have processor and memory architecture. Some of you are working in that space. And the challenge is going to be how do you present a problem how do you match a problem set and a data set to the computation fabric to optimize the workloads, which are principally NLP, machine learning, and graph analytics. Those workloads look very different than transactional workloads. So building processors that are really optimized for those workloads is really the subject of the second piece of work, learning and reasoning. And the third, which is really interesting, is moving towards new ways to interact, understanding tone, gesture, flexure, understanding subtleties in an image, understanding subtleties in speech. We have a piece of work, I mentioned this morning, with our neuroscience team to identify early precursors for Alzheimer's and other neurological diseases based upon changes in tone and changes in speech. And the published work in Nature and elsewhere has identified ways to identify this even 18 months or 2 years ahead of when first onset is detected in a set of standardized tests. Remarkable work. But it all sort of focuses on subtleties in new types of data, subtleties in speech, subtleties in text, maybe subtleties in writing. So these are three big areas that we're starting to see play out, and we've got significant research teams in each of these areas. The other two areas that are equally interesting, probably a bit further to the right. The first is I'm not sure how it's going to play out, but we're making the bet. The first is in building creative systems. Creative AI, is it going to replace people? No, it's not. There's not going to be anytime soon a US poet laureate in this space. But we have systems, we have machine learning systems and analytical systems that we've built that are composing movie trailers. Now, the movie was a bust, and it was a terrible movie, but this movie, Morgan, was kind of interesting. The trailer for that movie was generated by an IBM analytic team. Not the team, but by IBM Analytics, by Watson. And Watson, so we fed the entire movie, the full image-by-image film, I guess it's a film, not a movie, We fed the entire film into Watson to learn on. Watson selected the fields that would capture the intensity of the movie in the right sequence to capture the imagination and the interest of the reader, of the viewer. And Watson composed the trailer for Morgan. And the trailer, we heard from the studios, was quite a success. The movie was less of a success. But it was interesting that we took the leap, we made the leap between taking 2.5 hours of a film, having an AI system view the film, learn it. By the way, we used as training 6 other films and viewer experience on those other 6 films to establish what part of the what part of the Morgan film should be extracted for this 1-minute trailer. So if you go online, just go onto YouTube, look at Morgan trailer, the film Morgan, you'll find it. You'll see what's there. It was composed entirely by Watson. And I think it's like the first step of something that's pretty interesting. So if you think about what's the impact to the world of marketing and commerce to generate content that might be of interest to somebody that's going to buy something that's targeted to you or me or somebody else individually, becomes an interesting proposition. And so that's the thread that the research team is on, to try to understand how do we take insights that can be generated from a machine learning system to generate content that somebody can actually use. And your mind kind of, okay, what's next? There's all sorts of things next, but that's kind of the first stage in this. The other piece here that's interesting is a piece of work that's coming out of our Zurich team. And this is on cognitive discovery. And we were talking about this morning. That team is using Watson Analytics, again, our product part of the IBM business, but coupled with our research teams that are developing these product, I'll call them read-aheads, to build a system that intersects publications with simulation and test results. So we've used this in the metallurgical industry with 2 companies, and we're using it in pharma to try to understand how to synthesize new materials by looking at what have people published across a corpus that's pretty significant. What have we actually measured in the lab? And this is more than just filling in. This is more than just filling in another eutectic in a phase diagram. This is looking at new materials through fundamental understanding of material properties. We're just starting down this path, but it's an interesting path because this now is exploiting AI to cull a research corpus that no researcher can understand on his or her, in his or her time in 24 hours a day. Just couldn't do it. Thousands of papers published. You'll get a few of these, but you'll never get the right ones, guaranteed. But Watson ingests this and learns on it, and it becomes part of that analytic profile. So we're starting this work, and it's pursuing. The third one that I didn't list on here, but I think it's equally interesting. Why would I not expect this, right? So out of our Haifa team, they built a debating system. Why would I not expect this? They built a system that will debate in a debating format, debate a thesis for or against with a typical debating architecture. By the way, we've tested this with the Yale debating team, and we typically beat them. Don't tell them that, but not to leave here, not to be published, please. But we put forth a proposition, and the Watson debater will be on the for or against side of that proposition. And it does 2 things. First one's kind of trivial, the second one's really interesting. First thing it does, it goes and pulls up arguments in the literature that are for and against, and it composes a train of thought based on those arguments. Some of that's obvious, some of it's actually not obvious because it actually synthesizes events that aren't explicitly published. That's a hard piece of work by itself. But the other thing it does, which is equally interesting, actually more interesting, it watches the other debating team, as a good debater does, and tries to formulate an argument in response to what my opponent is saying. Boy, wouldn't that be nice in politics? So they're doing that. And they actually have a system. You can go online, you can take a look at what we published in this space. The HIFA debating team, they're pretty far along. I've asked them to build a second debater, because I actually want to see how two systems will interact. It's actually an important question. If a system is, learns a field, does it become more proficient in that field going forward in debating those arguments? You'd expect it would. Well, we ought to test the case. We ought to build a few of these and see how they work out. By the way, if you have kids, you don't want to give this to kids, but this is it's kind of interesting. So the reason I mention these is these are ideas that we're working on at IBM Research that are a bit further out from the horizon of what's available today commercially. In fact, they're pretty far out. But they take the creativity of a research team, and that team is starting to explore how is this world going to look as we go forward, and how might we start building that world together. It's going to happen. It's a question of how it's going to happen. The substance of all of this and the business proposition for all of this, the reason that IBM makes this investment in research is to drive insights. It's to drive insights at speed. Many of these insights, businesses just simply can't capture otherwise. You've all seen pretty important work, the work that GE has done, not in selling jet engines, it's pretty important, but in selling propulsion as a service. So how do they actually do that? Is anybody here from the Aero Astro department? Or does anybody know how? How does GE sell propulsion as a service? Anybody know? Somebody must know. Anybody flying a jet? Anybody flying a jet with a GE engine? Well, they've populated their engines with sensors to the point where they understand the failure, they do predictive failure analysis of that engine, and they'll pull it out of service just in time, and they know preemptively what their revenue loss, what the airline's revenue loss will be, and they guarantee the airline a certain uptime if they buy that engine for the platform that they're purchasing it for. So for United Airlines to buy a GE engine, United has absolute certainty that that aircraft is going to be up a certain percentage of the time, meeting all the FAA requirements, because GE has supported that with enough analytics and enough understanding to say, I can take that engine out of service. It's going to be out of service for 3 hours on this day, 6 hours on that day, and you can pre-plan your routes accordingly. So it fundamentally changes how a company utilizes its assets. And these are capital-intensive businesses. So the utilization of those assets becomes really interesting. And if you can improve the utilization by a few percent, it's a big deal for these companies. So in capital-intensive environments, insights drive revenue, insights drive competitive position. And we're seeing this across, again, every industry. Commerce is a great example, right? Who in this room is not an Amazon Prime shopper? Everyone is. Jeff Bezos would love you guys. I mean, look what they've done. They've got a remarkable platform, right? We all use it. I got stuff showing up every day at home. You know, my wife picks up most of it. Some stuff I shuttle away, but it shows up every single day, right? And we don't think anything of it. Well, what's the underlying analytics behind that? How do they select their price point? How do they select their shipping strategy? How do they select their competitive position relative to the bookstore down the street? All this is done by understanding enormous amounts of value to give them just enough profit on those products that you're likely to buy. And by the way, if you ever click on something and don't buy it, God help you, because you'll see that thing show up for the next 3 days. So, one of my hobbies is photography. I bought a pretty nice camera. I bought a Nikon D80 camera, really nice camera. And I needed a few lenses. I made the mistake of going to look at a few of these things online. I bought one, and all of a sudden I'm barraged by the other ones. But the other ones, it was interesting as I looked at this. I'm going to have Watson kind of do the analytics. The offers that I got were just close enough to what I could afford, what I wanted to buy, that I didn't dismiss them. Right? No way am I going to buy the Leica lenses. Really nice lenses, but I'm not going to buy those. But I might actually buy this other one that I've been looking at, and I keep getting the recurring, and it is not by happenstance. It is not by coincidence. And that experience tells me a lot about how these companies are structuring their place to their customers. So you're seeing analytics and insight drive every industry, and we're seeing it as consumers. The underlying part of this is the research foundations that are required to keep that going. Let me give you one example of some work that we did, our team did in Beijing. Who here has been to Beijing? Many have. What's the first thing you notice when you get out of the Beijing airport? Air quality. First time I landed in Beijing, it's actually interesting. So in the Defense Department, I spent a lot of time looking at that part of the world. My first trip as an IBMer was to Beijing. It was just me in a bag. Very interesting. But when I landed and I looked out, it looked like pea soup. In fact, it was noxious. Well, we've got a team of 200 researchers in Beijing. They're just northwest of the fifth ring in Beijing. And they have small children, they have elderly that live with them, and they were concerned about the air quality. And they said, we've got this thing in IBM doing analytics and forecasting of weather. And we actually had another piece of work doing understanding of molecular flow and chemical interactions in the atmosphere. We ought to be able to build some models that help us understand predictively what's the air quality going to look like. This was a team of 4 people. No one asked them to go do it. They just sort of said, this is an interesting problem. So this fellow calls me and says, I'm thinking about doing this. Is it okay? I said, you don't have to ask me. Just go do it. Go see what you can do. And I visited them about 6 months later. They had a team of 6 or 8 people. They had taken the data from 35 sensing stations around Beijing, and they had built flow models, 3D flow models across Beijing at 1 block increments across Beijing. And I said, well, that's good enough, but it's not really good enough. You need higher density. I want to see the dynamics. I want to see the temperature. The temperature influences, pressure and other influences. He said, okay, come on back in 6 months. Came back in 6 months, they did it all. In fact, they did this, they're working with the Air Quality Control Board in Beijing, and they're able to predict air quality 7 days ahead of the event. Now, why is the state government interested in this in China? They're interested in this because they want to tax companies to tailor their industrial output, which is about 1/3 of this problem. 1/3 of it is industrial output, about 1/3 is dust from the Gobi Desert, and about 1/3 is home emissions from principally coal. But they think they can tailor the industrial output piece to adjust the air quality in Beijing. So we've worked with them, or the research team has worked with them, and we've scaled this out to now forecast the air quality across not just Beijing, but all of China, and we're starting to do this as well for India. And the reason I mention this is a big data problem. It's exabytes of data per day. It affects billions of people, not just in China, but in India and Pakistan and elsewhere. And this project started with a seed idea of a few researchers that said, I'm living in an environment that I don't much care about. I need to fix it, and I want to use technology to solve this problem. And so we gave them a little bit of latitude, and it's now turned into a pretty significant event for IBM and for those countries that we're working with. It's a great example of analytics. This isn't exactly Watson, but it's traditional analytics. We'll use machine learning going forward, but it really does drive impact across a large population. And then on the hardware side, I mentioned this transition to AI computing, to quantum, and to the Internet of Things. 3 big physical science areas for the graduate students that are here. These are the big areas that we're starting to see pay out. So if you're looking at leveraging your insight here at University of Michigan, what's the next big thing? What's it going to look like? We are making significant progress in each of these areas. For those that are here, if you haven't logged into, I'm not going to go through all this stuff. You can have it. If you haven't logged into the IBM Q environment, has anybody here logged into this? Come on. Are there any physics students here? Nobody from the physics department. So have you logged into IBM Q? You haven't? Have you taken quantum computing, quantum engineering, quantum mechanics? Yes. How'd you do? All right. Of course you're going to say, well, this evening or this weekend or sometime, just do a search for IBM Q. So we have a 50-plus qubit system that we just announced. It's available online. You can actually, you just get a user account. It doesn't cost anything. There's no PayPal or anything. Just log in. There's a little script file that script language that we've written. There's a tutorial and a script language we've written. And you can actually program the arbitrary waveform generators that drive each of the qubits. And you can run those experiments in our 10 millikelvin system at IBM Watts in Yorktown Heights. We've had closer now to 40 publications in the scientific journals of people that have used this system to generate research quality results and published in the literature. So if you haven't, everyone here has read about quantum computing. You can go try it. The cost is zero. Cost is zero. You ought to try it. Interesting story. My 92-year-old dad, graduate of University of Illinois and MIT, the other way around, physics major. I told him about this, and within 2 days he logged on. 3 days later he calls me, he said, Zach, I've already written 3 programs and I've run them. I had this little problem with the 4th qubit. The entanglement range is a little bit off. Can you tell me what's going on? I said, Dad, I haven't run any programs yet. He said, you better get on it. And we talk like once a week, and he's like running programs every week. Pretty amazing. So it's easy to log on. You got to try it. We've had something north now of almost 60,000 users use it, and it gives people a sense of what's real and what isn't. And the reason we did this, so we have a major push in IBM to offer and to build out a set of universal quantum computers for industry. And there'll be several that you'll see in the news shortly. But we also have the charge to make sure we understand the fundamentals, the scientific fundamentals of substance below all this. And the best way to do that is to engage with the community at large. So we've opened this up. We opened it in May of this year. And by the way, the doors are not quite the size of this table, and we've got quite a few of them. So you can actually, this evening, take an hour and take a look. I think you'd find it pretty interesting. So that's probably the most far-looking research topic that we have across IBM Research. And it's kind of interesting. We're in the space now of working with clients on real engagements in quantum computing, while at the same time we have research teams that are pushing the fundamental science that underlies this. And the idea is to scale this out, not just on the physical side, but actually build the algorithms, maybe couple these to machine learning systems. Maybe these are going to be the elements that drive machine learning going forward. We're exploring that connection, but absolutely this will be something that will prevail. And with all of that, the last two things I wanted to say, I'll be here next week to find your best and brightest, right? So we hire across IBM about 100 University of Michigan graduates a year across all of IBM. And we really are looking for, remarkable talent, creativity, and passion in the work that you do. So you can see all these things. We'll be back next week. And it's, very simple story. Remarkable team, remarkable technical depth. We're not sort of the appendage to a CEO. We are really defining the future of IBM and the future of industries. And that makes our work really interesting. With that, let me take a few questions. Hopefully that gives you a sense of what we do.